Hello, in this lecture we are going to learn about object-oriented concepts. Many of the pictures I used in this presentation are taken from the classic book by Grady Booch, Concepts of Object-Oriented Programming. Let us begin with the problems faced with procedural languages. What are procedural languages? Languages like Fortran, COBOL, C, etc. are known as procedural languages. The main problem with these languages is that data does not have an owner. This leads to a problem of difficulty in maintaining the data integrity. Why is it so? The main building blocks of a procedural language are functions. Whether it's a Fortran program or a C program, functions are the building blocks of the program. Now, many functions can modify a given block of data. So, when the data gets corrupted, or something goes wrong with the data, it becomes very difficult to pinpoint which function has misbehaved to create the bug. Here's a picture. We have here function 1, function 3 and function 2 all are using a shared data. The other problem with procedural languages is the very common bug of uninitialized variables. One of my favorite programs which I ask my students is this program: declare an int k and print the value. It usually prints some unknown garbage value, and this is a problem of uninitialized variables. Another big problem with procedural languages is the resource deallocation problems. What are resources? Resources can be anything starting from memory to files to open database connections and network connections. What happens in this code here? We have declared here int star kp, and we have allocated a block of 1000 bytes to this pointer kp. Again we have allocated another 1000 bytes to this pointer kb, and yet again we have allocated 1000 bytes to the pointer kb. Now at the end of this code, 2000 bytes of memory becomes unavailable to the rest of the program, causing what is known as a memory leak. Memory allocated but unusable because we have lost the pointer to that memory. Another big problem with procedural languages is the insufficient support for abstraction. Let us take a case of an abstract data type. An abstract data type has two parts. One is the definition of the data. Second is the definition of the operations or functions which can be applied on the data. Now, in a language like C, the data can be modeled as structures, but the functions are global and not related to the structure. Now let us see what is abstraction. Abstraction focuses upon the essential characteristics of some object relative to the perspective of the viewer. This definition is from the classic book by Grady Booch, and this is a picture which accompanies that. You can see it is the same cat, but from the viewpoint of the owner, the old lady on the left, she sees it as a cute little fur ball which eats some food and makes cute little sounds. But from the viewpoint of the veterinary surgeon on the right, the cat has got parts like kidneys, intestines, bladder, liver, etc. So the two people have different abstract models of the same cat. Let's come back to the problem of ADTs and modeling them. Suppose we have a structure stack here which has an int top and a char star store. This is the array. Then we have two functions, push and pop. In the same program, we also have a queue which has a structure with a front and a rear and a store. It has functions insert and delete. Now, in a typical C program, all functions are global. The push, the pop, the insert and the delete functions are all global. That means the program has no way of knowing that push and pop belong to the struct stack and that insert and delete belong to the struct queue. Or in other words, insert and delete are not applicable to stacks, push and pop are not applicable to queue. The compiler has no method. Let's take another example of a structure horse which has a weight, a color and an age as its members. And we have a structure eagle which has a 8, weight and a wingspan. The eagle flies and hunts. The horse can gallop and canter. Now all functions are global. That means the C compiler has no method of knowing that horses cannot fly and that eagles cannot gallop. So if there is any illegal call, it has to be handled at runtime and it could lead to some errors. Let us see how we can get better abstraction using an object-oriented language. Here we see a stack where the pop and the push functions have been pushed into the class, and similarly the insert and the delete functions of the queue are pushed into the envelope of the class queue. Now with this information, the compiler knows that these two functions belong explicitly to stack and that the insert and the delete function belong explicitly to the queue_ADT. Now if I try to use the insert on a stack or a push on a queue, the compiler can give an error. So we say that a class is the definition of the state and the behavior. The state is defined by the data members, the top and the char star store for stack, the front and the rear and the store for a queue. The behavior or the set of operations which are valid for that given class are defined by the operations or the functions, the push and the pop for the stack, the insert and the delete for the queue. In the same way, we can now see that for the horse and the class, the functions of the horse, gallop and canter, have been encapsulated inside the class, and the functions fly and hunt have been encapsulated into the class eagle. Now the compiler can catch an error of a flying horse or a galloping eagle very easily. Once again, class equal to state plus behavior. The state is defined by the data members or the fields of the class, by the age and the weight and the wingspan of the eagle. The behavior of the horse is defined by the two functions gallop, canter. The behavior of the eagle is defined by the two functions fly and hunt. Looking further on the class equal to state plus behavior equation, the state is often referred to as data members. If we are talking about C++ programs, in other languages like Java, they're known as fields. Visual Basic programmers like to call them properties, but these are just the different jargon used in different programming languages. Similarly, the behavior is defined by what are known as methods. In languages like Java, C++ programmers like to call them member functions. But do remember that these are one and the same. What is an object? Again, the definition from Grady Booch. An object has state, exhibits some well-defined behavior, and has a unique identity. This is again the picture from the Booch book. It has a state. It looks like this. The hammer looks like this. It has a behavior. The hammer is used to hit nails, and every hammer is different from the other hammers out here. A class represents a set of objects that share a common structure and a common behavior. Once again, a definition from the Grady Booch book. This is the cartoon which represents that a class is a set of objects which are similar. Now, suppose I got a garden. Let's talk about other issues. I got a garden in which I'm growing different kinds of flowers. The garden is public. Now that creates a problem. It faces a threat from people, from donkeys and from rabbits, which might attack the garden in different ways. We got a problem. How do we solve it? Suppose I build a very high fence around my garden, very high fence around my garden, and enclose the complete garden. My flowers are safe, but I got a new problem. I can't use my own garden. Let's go to the next solution. Now we have a private garden with a guard. I hire a guard, and I give him proper instruction as to who is authorized to use the garden and who is not. Now, outside people who come to use the garden have to take the permission of the guard to be allowed to do any operation on the garden, and this keeps my garden safe and I can access the flowers for my own use. So we have write functions to safeguard data. Suppose this is my data, int x, and there is a rule that x must be between 0 and 100. This is some kind of a business rule which comes from the problem statement. So any request to change x does not work directly on the data as it would work in a procedural language. It must send the request to my function will then try to change the value. This is the concept of the outside world talking to the guard. The guard is allowed to access the flowers in my garden. Now let's see what it looks like in code. This is my function modify x. The guard function sends a new value. If the new value is illegal, then I print an error and exit. This is not code, I just written pseudocode. Otherwise, the value is changed to the new value. So by doing this, I'm ensuring that the business rule of x is less than or equal to 100 and greater than or equal to 0 is enforced at all times. The data integrity is never compromised. The read function looks like this. So the first law of object-oriented programming is encapsulation. Data must be hidden. All data is private. Read access through read functions and write access through write functions. For every piece of data, this leads to 4 different possibilities. Either we allow both reading and writing, that is, we can access the data and we can modify the data, or read only, that means we can access the data but are not allowed to modify. Write only, we can modify but cannot access in terms of reading. No access is absolutely no reading or writing. Encapsulation hides the details of the implementation of an object. This is a definition from Grady Booch. This is a cartoon from the Grady Booch. The internals of the cat, all these are the internals of the cat, are hidden from us. We only see the external interface of the cat. What does the cat look like from outside? Internal details are hidden. This is what is known as encapsulation. Now we have a new problem. If the garden had only weeds to begin with, putting the guard doesn't change it. This is the problem of improper initialization. So what we do is to initialize objects properly, we have special functions called constructors. Constructors ensure correct initialization of all data. They are automatically called at the time of object creation. The other problem of resource deallocation is handled properly through the functions called destructors, which ensure the correct deallocation of all resources before an object goes or dies or it is removed from the memory. In this slide, we look at the life cycle of an object. What we need is that object should be properly initialized, or in other words, born healthy. This is ensured using constructors. Objects should maintain their integrity of the data. That means functions should not be allowed to destroy the data or make it invalid. This is ensured using the read-write functions, and the objects should die cleanly, or when they go out of scope and are cleared up, they should deallocate all the resources which they allocated. This is ensured using the functions destructors. So we can see that the constructors are the Brahma, the read-write functions are the Vishnu, and the destructor is Maheshwara, the holy trinity of object-oriented programming. Next, let's look at the anatomy of a class, or the parts of a class. First of all, we divide all the parts into 2 areas. One is the private and the second is the public. The public part is what is visible to all other classes and through which other classes can interact with our class. So let's look at what do we have. First of all, we have the data, which must be private. As we have seen earlier, the principle of encapsulation says that data must be private. Next, we have the read-write functions, which are used by the outside classes to interact with our data. These are public functions. Next, we have the constructors and the destructors. And finally, we have the implementer functions, or the editing functions of the class. These are the functions for which the class exists. This is the set of functions for which we have developed our class. It could be run, fly, pop, push, whatever we have. In addition, we could also have some private functions which are used only by the other functions of the class and are not available to the outside classes. So this set of functions which are available to the outside classes is known as the public interface of the class. Let us look at another concept called inheritance, which is essentially code reuse at the binary level. So what we have is we have a class stack. It has functions pop and push. Now we would like to add another function to it, but now with a new complication. We do not have the source code of the stack class with us. That means we only have the binaries, we do not have the source code. How can we extend the functionality of the stack to another class called stack1? That means we want to extend the functionality of the class stack, or in other words, we want a specialized function which does everything that stack does plus something extra. A class may inherit the structure and behavior of its superclass. This is the official definition of Grady Booch in his book. So here we have a grandfather and a son who all inherit the obvious property of having a very long nose. Now, in the single inheritance, we get a tree structure, or what are known as a inheritance trees, based on the is a relationship. What do you have here? We can say that human is a specialized ape. Ape is a specialized mammal. A mammal is a specialized vertebrate. A vertebrate is a specialized animal. Please note that the arrow goes from the derived class towards the base class. So this forms an inheritance tree, or an is a relationship tree. Another simpler example would be example of a manager. Manager is also an employee, but with some additional features. So manager is an employee. It's an is a relationship. Now what is the best nomenclature when we're talking about these two classes in the inheritance tree? The best recommended one is base class and a derived class. The other two nomenclatures which I do not recommend are the pairs of words superclass and subclass. Somehow we get the idea that the superclass is bigger and the subclass is smaller. And similarly, when we use the words parent class and child class, we get the idea of a big parent and a small child. While in fact, the base class is smaller than the derived class, because in the derived class we have all the functionality of the base class plus the additional functionality of the derived class, which is extra. So in fact, in terms of the code and the number of functions, the derived class is larger than the base class. So we really recommend the use of the words base class and derived class when talking about inheritance. Let's look at multiple inheritance. Suppose we have a class called horse. We need to create a flying horse. One way would be to add the functionality of flying to horse and get it. Another easier way would be to derive its functionality from two classes, a horse and an eagle. We get the functionality of a horse from a horse and the functionality of flying from an eagle. So this leads to quicker code development. One class having more than one base class is known as multiple inheritance. When we have multiple inheritance, the inheritance structure resembles a graph. Here we have A, from which we have derived classes B, C, and class E is derived from B, class D derives from C, G is derived from E, and F is derived from F, is derived from B, H is derived from F, G, D, and A. One class can have multiple base classes. Now what happens is the structure of a graph is generally more complicated than a tree. This leads to the difficulty of maintenance of the code. Suppose there is a bug in the class H. We would have to examine almost all the codes of this tree or the graph to find the bug. Another problem which we get in multiple inheritance is ambiguity in function calls. So here's the structure of an inheritance tree in single inheritance, which is simpler and easier to maintain the bugs. Suppose you find that the code of gorillas is malfunctioning or there is a bug in it. We only have to check the code of apes, gorillas, mammals, vertebrates, and animals in order to find the bug. We do not have to examine the other classes. Another problem with the multiple inheritance is ambiguity of function calls. Our flying horse becomes hungry. It wants to eat. So should it eat like a horse or should it eat like an eagle? That is, should it eat grass and oats, or should it hunt rabbits and do something else? This ambiguity has different solutions, but all of them lead to further complications in the maintenance of the code. Next, we come to another feature of object-oriented programming, that is modularity. The modularity is the packaging of abstractions into discrete units. We have classes, we have packages, we have domains or namespaces. This is the picture of modularity from the Grady Booch book. Yet another very important feature of object-oriented programming is strong typing. Strong typing prevents mixing abstraction. This is the definition given by Grady Booch. What does it mean for us? Let's look at this simple statement. Y is assigned to X. This statement will be allowed in the language if and only if X and Y are objects of the same class. Otherwise, they are not allowed. So what would be weak typing? Weak typing would be to allow some violations, as in C, we can assign a float to an int and a int to a float. And the other extreme of an untyped language, or what is known as dynamic typing. For example, Lisp, JavaScript, etc., where variables have no type, they can take on any value assigned to them. What does this mean in simple words? Object-oriented programming languages avoid putting a square peg into a round hole or a round peg into a square hole. This is strong typing. Another feature is concurrency. Concurrency allows different objects to act at the same time. An example would be Java support of multithreading is a form of concurrency. Different objects acting at the same time. Another major issue is persistence. This is a major issue in modern object-oriented programming languages. How do we store the state of a class or an object in permanent storage media? That is, while my program is running, the values of the variables of the object are stored in random access memory, that is volatile memory. How do I store it in permanent storage so that I can close down the program and restart it after some time and get back the values? So this is what is known as the problem of storage or persistent storage. So there are different techniques allowed in different languages. Object serialization is supported in Java and in C# and many other languages. This also leads to different schemes of storing objects in a relational database management system using what are known as object relational mapping schemes. We are trying to store the cat in permanent storage here, picture from the Grady Booch book. So to recap, let's look at the 4 major features of object-oriented programming. They are abstraction or modeling, encapsulation or implementation hiding, inheritance, which could be single or multiple, and modularity. And the other 3 features, which are also very important for object-oriented programming in the modern context, are strongly typed, and they should support concurrency, and there should be a mechanism to persist the state of objects across time. Thank you very much. Thanks for your patience in going through the video on object-oriented concepts. If you want to send your comments and queries, kindly send them to my email ID ravipireddy@gmail.com. I hope you enjoyed it. Thank you very much once again.